Hello students, I am Poonam Bujani from Marwar University. Welcome back to the series of the flip-flops of the sequential circuit design. I hope you have seen the last videos of SR, D and JK flip-flop. Today we are going to study the last flip-flop, that is the T flip-flop. So let's see the operation of the flip-flop and the same different tables of the flip-flop which will define the characteristics of this T flip-flop. So let's go through it. T flip-flop and JK flip-flop. Now you can compare both the flip-flops together. See, if you will short the both inputs J and K together, then only single input will be there, that is known as a T. And T flip-flop is also known as toggle flip-flop because this flip-flop is specially designed for the toggle condition when T equal to 1, that is you can say that J and K both are 1 1. So as a formality, let's study the different cases of this T flip-flop. One control input clock is connected with the AND gate. T input is connected with the both AND gate as an input. And the third input of AND gate is the feedback from Q and Q dash. So let us take the first condition, that is clock equal to 0. So we know that in AND gate, if clock equal to 0, that is one of the input is 0, then whatever T is there, whatever Q and Q bar is there, output will be 0 0 for sure. Right, so this AND gate will give you 0 0 output. Now whenever RS latch will be having 0 0 output, this will work in a no change condition, or you can say that in a storage mode. So this whole flip-flop, T flip-flop, will be in the storage mode when clock equal to 0. Now if clock equal to 1, then AND gate AND gate output is dependent upon the other inputs also. So let's take the other input T and the different feedback output, but let's consider the first case, if T equal to 0. Then here if T equal to 0, this 0 will go to the both AND gates. So again this AND gate does not depend upon the feedback input, because if one of the input of the AND gate is 0, output will be 0 for sure. So again your RS latch is having the 0 0 input, so output will be in the no change condition. It means whatever present state you will assume, that will be the next state also. So if Qn equal to, let's say 0, Qn plus 1 equal to 0. If Qn equal to 1, Qn plus 1 is also equal to 1. Right, so it is known as in no change mode when T equal to 0. Now the next state, let's say T equal to 1. So here clock equal to 1, T equal to 1 will go to the both AND gates. So now these AND gates are dependent upon the third input. So let's take the first condition, Q equal to 0. So if Q equal to 0, Q bar will be 1. Right, so this 0 will go here and this 1 will go here. So AND gate, one input is 0, AND gate all three inputs are 1, so this AND gate will give you 0 output, this AND gate will give you 1 output. So in RS latch, if S equal to 1, R equal to 0, this will be in the set condition. So if present state is 0, next state will be set to 1 in T flip-flop. Now let's take the opposite case of Qn, that is if Qn equal to 1. So this one will go here, this 0 Q bar will go here, and the AND gate, first AND gate will give you 1, upper AND gate will give you 1, and the lower AND gate will give you output 0. So in this case R and S will be opposite to each other, that is R equal to 1, S equal to 0, and whenever R equal to 1, the SR latch will be in the set condition. So whole flip-flop will be in the set condition, and if your Q given was 1, then next state Qn plus 1 will become 0, that is reset condition. Right, so can you say that T equal to 1, obviously T equal to 1, then J, K both are 1 1, it means it is a toggle condition, and same thing we are getting here. So if Q was 0, then we were getting Qn plus 1 1. Here Qn is 1, so Qn plus 1 will be 0. So this is in conclusion you can say that this is in the toggle condition. Now let's see the truth table or characteristic table of the T flip-flop also. So T and Qn together will make the 4 different conditions when clock equal to 1, and when clock equal to 0, whatever T is there, Qn plus 1 will be Qn only. right? That is in a storage mode. So if clock equal to 1 and t equal to 0, then output is in the storage mode, qn plus 1 equal to qn, that is in a no change condition. And if clock equal to 1, t equal to 1, then qn plus 1 is in the toggle mode, that is 0 will become 1, 1 will become 0. So if you will put this qn plus 1 in the k map, then you will get the equation like this: qn plus 1 equal to t dash qn plus t t qn dash. That is same as the XOR gate. Why? Because this truth table is same like XOR, right? So this truth table is same like XOR condition. So t XOR qn equal to qn plus 1, that is known as a characteristic equation of t flip-flop. Let's see the state table. We know only two states are possible. If t equal to 0, the state is no change. If t equal to 1, state is toggle condition. And yes, if clock equal to 0, then the qn plus 1 will be in the storage mode. And the last table, that is excitation table. In excitation table, if q1 equal to 0 and let's say we want the desired output, next state output as 0, then obviously the output is in no change, means t should be 0. If q1 equal to 0 and we want toggle the output, it means t equal to 1, then only this toggling condition is possible. Same way 1 to 0, again toggle condition, and 1 to 1, that is no change condition. See here we cannot take set and reset condition, because in T only two conditions are there, that is no change in these two cases and toggle in these two cases. So your excitation table will be something like this. So here we have seen all the different flip-flops, that is SR flip-flop, D flip-flop, JK flip-flop and T flip-flop in this different 4 videos by using NOR gate concept. But let me tell you that all these 4 flip-flops are possible to make by using NAND gate also. NAND gate is also a universal gate, and by using NAND gate also you can make the SR, D, JK and T. So students, it is your exercise. Verify this circuits and find out the characteristic table of all these 4 flip-flops. Are you getting the same as you are getting in the NOR gate, or it is different? Right? And verify your answers with the respective faculty of your class. So in the flip-flop, we have studied all type of 4 flip-flops, and then in this session, I can conclude that we have studied first of all latch versus flip-flop. What was the difference between the latch, what we have studied in the previous video, and the flip-flops, what we have studied in this 4 videos. Then before going to the flip-flop topic, we have also seen the concept of clock in flip-flop, because clock is very important parameter in all digital devices. Then we have studied the working of all these 4 flip-flops, characteristic table of all flip-flops, state table of all flip-flops and excitation table of all flip-flops. So I hope you understand this flip-flop and latch topic clearly. Thank you.